Hey, I'm going to do some problems from 6-7. Start with number 5. Directions here say a particle moves along an s-axis, whatever, x-axis. Use the given information to find the position function of the particle, which I guess we'll call s of t. So in part A here, we've got a velocity function, which is 3t squared minus 2t, and they're telling us that the starting position is 1. So understanding the relationship, the calculus relationship between position and velocity is very important. And I would like you to write out this, what I would think of as an expression of the fundamental theorem of calculus, that the integral from somewhere to somewhere, we'll figure that out in a second, is equal to that's like fundamental theorem, what we called part 2. So now what do I put here and here? Well, I'm just trying to find the position function. So I'm going to go from 0 to t, but then I have that double, there's that annoying thing where you're not supposed to use the same variable. So I'll just make these ones x's. I really want this one to be a t, right? Because I'm looking for s of t minus s of 0. All right, so what is the, and did I forget a square on that? I did. What's the antiderivative of that? So this is t cubed minus t squared from 0, v of x, should be x's in there. It's really just like a formality, right? It shouldn't really mess us up at all. S of t is what I'm looking for, trying to make a position function, minus s of 0, which is 1. So now I just drop the t's in, and I get that the position function is this, with the t's in there, plus 1. Now, if you're looking at that and you're thinking to yourself, okay, now I just found the antiderivative and then did like the plus c and then set this, use this to solve for c. You can do that. That totally works. I just really think that there's great value in just like expressing the fundamental theorem in this form as often as possible, just to really bring that home. So how about this? So we're going to have to go 2 levels here to get back to position. So let's see. The antiderivative from, looks like 0 to t of 3 sine 3x, I'm using x's for the same reason that we just talked about, is going to be equal to the velocity at time t minus the velocity at time 0. So there's that. And let's see, the antiderivative of this, antiderivative of sine is negative cosine, and then you divide by the thing inside because it's just like a linear multiple of x there. So that's negative cosine 3x. Don't believe me? Then just take the derivative of this, just do a quick check. Oh yeah, it's that because of the chain rule. So all good. So the velocity function is negative cosine 3t and then the cosine of 0 is 1, so that's actually minus 1, and then I'm going to plus the 3. I'm going to plus the 3? Who says that? Minus 1, and then I'm going to add the 3, so that gives me a plus 2 there. And then I know that the integral from 0 to t of the velocity function, which is negative cosine 3t, oops, should have done an x there, dx is equal to position at that minus that, right? Fundamental theorem again. Antiderivative of negative cosine is negative sine. And then I got to divide by that 3 again, so negative 1/3 sine 3x. The antiderivative of 2 is 2x. It's 3. All right, so it looks like I got negative 1/3 sine 3t plus 2t. Now the sign of 0 is just 0, so that's plugging the 0 in here. Everything goes away, and then plus, I'm going to plus that 3 over there again, and that is my position function. I'm just glancing at the solution manual there, and they have they get a 4t there. How did they get oh, I made a sign mistake here, didn't I? When you plug the 0 in, it's minus what you get when you plug that in, so it's minus negative 1. Sorry, I'm cutting too many corners there. Got me in trouble. So it would have been a 1, and then I have to plus the 3 over to that 1, so this should have been a 4. And that would be 4x, and then this would be a 4t, and that should be in agreement with the rest of the world. Sorry about that. All right, number 7. We got the velocity time t is 3t plus 1, and s of 2 is 4. Okay, so make that an x, 3x plus 1 dx. I'm going to go from 2 to t. Why am I starting at 2? Because 2 is the thing that I know about. I don't know about 0 here, so it doesn't make sense to go from 0 to t. Got to go from 2 to t, because I know this. Because on this side, I'm going to have my s of t minus s of 2. This minus this. Right? Okay, so that gives me, the antiderivative of this is 3/2 x squared plus x. And s of 2 is 4. So it looks like my position function is, when I plug the t in here, I get 3/2 t squared plus t. And I plug the 2 in here, I get 4. Now this is minus this. Don't make the same mistake you made here, dummy. So minus what I get when I plug 2 in here. When I plug 2 in here, I get 4. 3/2 times 4 is 6, plus 2 is 8. So that's minus 8, and then plus 4, and so that's minus 4 at the end. And the College Board, and you know, me, because I am their pawn, their stooge, do their bidding for them. Henchmen. You can leave it like that. Did you know that? Doesn't matter. So they don't care, so hey, I don't care either. I mean, I know you could do that, but that's minus 4. Just checking that. All looks good. And then B, we got to go the 2 levels again because we're starting with acceleration. I'll do this one the other way with the plus C's, and you can see what you like better. Both of the methods are totally legit. So this, if this is the acceleration function, then the velocity function is the antiderivative of this, which is t cubed over 3 minus 3/2 t squared plus t, and then plus c. That's that general antiderivative. And then I know that v of 0 is 0, so I can plug that in and solve for c. In this case, that just gives me 0. So ut is equal to t cubed over 3 minus 3 halves squared, 3 halves t squared plus t. And the c came out to be 0, because it's just a polynomial. And when you plug in 0, you need to get 0, so c must be 0. And then to get back to position, antiderivative of this would be t to the 4th over 12 minus 1/2 t cubed, right, because I bumped that up 1 and then divide by 3, so that's going to be that. T squared over 2 plus c. And these are different c's, so just to make sure that I don't get confused, I might just call that one C1 and this one C2, right? Because they're not the same C. Actually, in this case, they are. They're both 0, but they're not like in the setup. They're not. They do turn out to be both equal to 0. But actually, yeah, I would stick by that claim that they're definitely not the same. They do happen to both be equal to 0. So the position function is just that. So I guess that was a bad example to show you how to do it this way, because plugging in 0 here just made 0 equal to c. If you had some other, say, more interesting numbers here, you would have to plug this in, of course, over here, and then that's the value that would go here, and you'd have to do a little math to figure out what the c is. It's not always 0. Even when your initial velocity, initial position, even when those are 0, it doesn't necessarily mean that that c is going to be 0. Okay? Number 9, different directions. Particle moves with a velocity v of t in meters per second along an s-axis. Find the displacement and the distance traveled by the particle during the given time. All right, so 9a, got velocity equal to sine t, and we're going to go 0. Sorry, I'm going to write that in interval notation. 0 to pi over 2. Okay, so we want in displacement and distance traveled. So displacement is just the integral, the area under the velocity curve, and that's equal to, I happen to know that's equal to 1, right? And the total distance, that is where we need to do this. And we don't have any rules for finding antiderivatives or derivatives of things in absolute value signs. You have to do that on a case-by-case basis. In this particular case, because the sine function from 0 to 2 pi over 2 just looks like this, it's all positive, so it's not any different from this. It doesn't change it at all. So sometimes we use our calculator to do this, depending on the context. Sometimes you just have to look at the separate areas and figure out the positive version of those by breaking up the interval, whatever. Oh, and there's units here, so since that was meters per second, that would be those would be meters. So how about if the velocity function is cosine t from pi over 2 to 2 pi. I think we've talked about this before, but you know that the if you have a sine or a cosine function that has not been stretched or dilated or anything, that the area of one bump of a trig function, that this area is 2. So I think we could probably use that fact to do both parts of this one. So the displacement is going to be from pi over 2 to 2 pi. We just want the straight up area of the cosine function. So So we can use like once we know this, and so that must be 1 because of the symmetry of this. I think we can do it by just looking at the geometry. So from pi over 2 to 2 pi, we're talking about this. So each one of these is 1. So the straight up integral, allowing for negative area, these two are going to have to be negative, and that's positive, so it's going to be -1 meter there. And the total distance, that's all the positive area, so that's going to be, just write this out. Absolute value, that's going to be 3 meters. And just to make extra sure that you know how to do that, that your calculator knows how to do this, I'm going to make sure that I am in radian mode because I'm doing calculus. And you can do math 9, that brings up your little integral, and do, let's see, pi over 2 there to 2 pi. And then in here, I want absolute value signs. Get those from the math menu over to number, and it's the first option. Absolute value signs there. And we want cosine, it's going to make an x instead of a t, that's fine. Dummy variable anyway. Dx. And that's what we just did here, so that should give me 3. Now, why did it do this? If you're curious about that and you're not sure right away, pause the video and just think about that for a second. Excuse me. It did this because the calculator is a stupid machine that doesn't know how to do calculus. So how is it doing this? Well, it's doing a lot of number crunching, basically making a little Riemann sum with a bunch of little rectangles and adding all the stuff up. So in the end, after it does that, it has an approximation, and it's a pretty good approximation, but in fact the answer is exactly 3. Like, this is not correct. If we're looking for an answer that's correct, we're using our calculator and we're rounding to 3 College Board decimal places, we're going to be good. So if that makes you nervous that it's not 3 and that it's off a little bit, I mean, it's a calculator, it's supposed to be right. Well, maybe not. All right, last, was that just A? No, that was both parts of that, right? Yeah. All right, so 11A, we got, for our velocity function, t cubed minus 3t squared plus 2t, and that's from 0 to 3. That's our interval. And we want to know the displacement, which is going to be the straight up integral here of that. So what is the antiderivative of this? It is t to the 4th over 4 minus t cubed. Is that a plus? That's a plus. Yeah. T squared plus c. Do I have to put a plus c in there? No, I don't, because this is fundamental theorem part 2, and it's a definite integral. So whatever c I picked, it would cancel out when I did plug this in and then subtract, plug this in. You'd have the same c minus the same c. So we always just choose 0, because that's the easiest. So let's see, 3 to the 4th over 4 is 20.25 minus 3 cubed plus 3 squared, and then minus, plug all those things in, you just get 0. So let's see, 29 1/4 minus 27, I guess that's 2 1/4. Let's see how we did there. Yep, meters. And the total distance, so what are you going to do with this? Well, you could try to find the zeros of this and then break up that integral. If you wanted to do it that way, like totally by hand, then that factors into t times t minus 2 times t minus 1. So this thing has plenty of zeros in this interval. It goes from, this is like a this shape cubic, so the first 0 is 0, and then it must have that positive bump, and then so it must be like this. So that means I would need to find 3 separate integrals. I'd need to go from 0 to 1, and then from 1 to 2, and flip the sign of that because it's going to be negative, and then from 2 to 3. I'm not going to ask you do a lot of things like that by hand, and I don't think the College Board is either. So what I would like to see you do is know how to execute that maneuver with your calculator. So let's do that. So I've got a math 9. I'm going to go from 0 to 3 and want absolute value signs. And inside I have x cubed minus 3 x squared plus 2x dx. And it better be bigger than that. So same deal as before. What do you think the answer is? It's exactly 2.75. All right. Is that correct? It is, according to the book. And then last one, number 11, B. Last part of the last one. So here I've got, let's see, t to the 1/2 minus 2, also 0 to 3. That's not going to be super pleasant, those numbers here with that square root function. Let's see what happens. So the displacement is going to be the integral from 0 to 3, t to the 1/2 minus 2 dt, which is bump the exponent up 1, divide by the new exponent, minus 2t, 0 to 3. When I plug the 0 in, those are going to go away. So it's just what I get when I plug the 3 in. So that's, yeah. Let's see. I guess the square root of, that's 2 times the square root of 3. You're going to have to take my word for that. I'm pretty sure that I did that right. Minus 6. Right, so this is, I'm thinking about this like t to the 3/2 is the same as t to the 1/2. So that's like a 3, that's like 3 square roots of 3. And so the 3 on the outside is going to cancel that out. So that's right. I wonder if the book has it written like that. They do have it written in that same way. And then total distance. Does this have any zeros in between 0 and 3? I don't think that it does. I think it's the zeros are at 0, or it's just at 4, right? So the total distance, well, what does this look like? That's the square root function, which looks like this, but dropped by 2 units. So like this, and it doesn't get to 0 until this gets to 4. So this, 2 times the square root of 3 minus 6, this is a negative number. So the total distance, since it's all underneath and it never crosses, it's the same number, but opposite sign. So it's going to be 6. minus 2 square roots of 3. Alrighty.